Make sure the
Yeah.
turbine, you know what I'm saying?
Facts. Make sure everything's on point. Makeup.
And we back with you guys. Let me
Yeah, because I sniffed right after I said that too. So
take two. He
we
said I
stayed we
sniffed.
stayed doing the take twos hella quick.
Right. Take two. Take three. What's good, y'all? It's Mr. Love.
And I'm Mr. Almond.
And we're back with y'all with another FRQ today. So this time we're gonna switch it up. We're gonna do a BC FRQ. So this is our first
Ooh.
BC FRQ that we're gonna
Mm-hmm.
do. For the BC folks out there, y'all's exam is the same day as AB. So we felt that it would be good to cover some BC content as well. Today's gonna be a series question. And
Ooh.
so I think last week, Mr. Allman kind of took it away and worked through that spinning toy question. And he had never seen it before, so he worked through it in real
Facts.
time with you guys. And
Yes.
I promised that I would do the same this week. So this is a series question. I teach Calc BC. I've never seen this series question before. I've done a lot of questions in my life and as a teacher, but I've never seen this one before. So we're gonna see how it goes.
Let's go. And I don't teach BC, by the way. So Mr. Love's gonna be teaching me as well.
Yes, let's hope I don't get nothing wrong. So I'm
Yeah,
gonna
we'll
try to go
see.
slow.
All right,
Let's get into it.
take it away.
All right, so it says let f be the function defined by f of x equals e to the x divided by 2. And so part A says write the first four non-zero terms and the general term for the Taylor series expansion of f of x about x equals 0. All right,
Okay.
so if you're in Calc BC, you have to pull up to the exam knowing the Taylor series for e to the x, cosine x, sine of x, and 1 over 1 minus x. So those are your main big four. So e to the x, sine of x, cosine of x, and 1 over 1 minus x. So they'll ask you about those four functions. And we know that Taylor series are really good because they basically take polynomials and they model functions, right? So you can turn any function into a polynomial if you know it's Taylor series. And this is easier to work with because polynomials are just real straightforward. So for e to the x, its Taylor series expansion is going to be 1 plus x to the second over 2 factorial plus x to the third over 3 factorial. And this pattern continues all the way up to the general term, x to the n divided by n factorial. And when you write your Taylor series, this is an infinite series. So you have to have the plus dot 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 at the end. Now I wrote that out as my Taylor series expansion for e to the x. We want the Taylor series expansion for f, which is e to the x over 2. So
Mm-hmm.
the nice thing about Taylor series is that we can just use substitution to build new series, right? So I know that e to the x over 2 is just a composition where I plug x over 2 in for the x and e to the x. So just as I did that on the left side here, I'm going to do the same thing on the right. I'm going to replace every x in that Taylor series expansion with x over 2. So this is going to be 1 plus x over 2. I'm using gold so y'all can see what's going on.
Mm-hmm.
Plus x over 2 is going to take the place of x. So x over 2 quantity squared over 2 factorial. And we want the first four non-zero terms. So I got to go out one more term here. X over 2 quantity cubed over 3 factorial. And then we also want the general term as well. So the general term is the term with just the n in it. So I'm going to go plus dot dot dot, and then replace my general term with x over 2 quantity to the n over n factorial. And don't forget your plus dot 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 at the end because this is an infinite series. So this would be the first four non-zero terms and the general term for the Taylor series. How
Okay.
did I do in part A, Mr. Almer?
So as I look at the answer key, exactly what you have, including the plus dot dot dot.
Okay, cool.
Yeah.
Okay, cool.
The only thing that they added, they said that all that was equal to the sum from n equals 0 to infinity of x to the n over 2 to the n times n factorial. I don't know if
Yeah,
that's where
that's
that comes from or
that's kind of writing it more in sigma notation. So if you
yeah,
want to
yeah,
write
yeah.
all these terms in sigma notation, you could write it as the sum starting from n equals 0 to infinity. And then you could simplify, the expressions on the inside. So that general term, I could take that 2 to the n and put it
Mm-hmm.
to the denominator with the n factorial. So that would just be x to the n divided by 2 to the n times n factorial.
Right.
You want to simplify it.
Okay.
All right, so that's part A. So just knowing what your Taylor series is for e to the x, and then knowing how to do a substitution.
Okay. So would that be what, 2 points?
That would probably be 2 points. A
Yeah.
point for the first four terms and the general term.
Got you.
Probably.
Okay.
All
Nice,
right.
nice, nice.
Okay, so on to part B. So we 2 for 2 so far.
Yeah.
All right, so it says use the result from part A to write the first three non-zero terms in the general term of the series expansion about x equals 0 for g of x equals e to the x over 2 minus 1, all divided by x. So in part A, we use the series for e to the x to construct a new series for e to the x over 2 by using a substitution.
Mm-hmm.
We're going to continue that in part B by taking the series that we know we constructed for e to the x over 2. And all we want to do is just subtract 1 from all those terms and then divide all those terms by x. And we can do that. We can
Mm-hmm.
take series because they're polynomials. I can just add, subtract terms off, and I'm still good, right? So I'm going to say g of x is going to be equal to e to the x over 2. So that's that whole thing from part A. And let me see. I'll rewrite it over again. It's cool. Plus dot dot dot, all those terms. And I'm taking that, I'm subtracting a 1 off. I'm dividing everything through by x. So what happens really is this 1 will add to 0 with this 1. So that cancels out. So then now I just have x over 2 plus x over 2 squared over 2 factorial plus x over 2 cubed over 3 factorial plus dot dot dot, all divided by x in the denominator. And notice this question asks for the first three non-zero terms. I'm probably because of that one that canceled out. So they only want you to go to three
Mm-hmm.
places, three
Mm-hmm.
terms. So now this is cool because if I have a sum of terms in the numerator, right, we know from third, fourth grade that way you can just break up fractions, right?
Mm-hmm.
So every term here
Divided by x.
just gets divided by x, right?
So this
And for
seems like more of
algebra,
like a arithmetic type of thing.
yeah, it's just really algebra, right? Like if your
Yeah.
algebra is good, you know that when you divide by x, it just knocks the power of x down by 1. So this first term in the numerator, instead of it being x over 2, it's just going to be 1 over 2. So 1/2.
Mm-hmm.
And then the second term is x squared, but I divide by x, I get x. This is going to be x. And I'm going to actually go ahead and simplify. I still have 2 squared, and then I have a 2 factorial. So I'm going to have
Mm-hmm.
over 2 squared times 2 factorial in the denominator like that. And then the last term, I have an x cubed divided by x, I get x squared. So I have x squared. And then the denominator, I have 2 to the third power times
Times
3
three
factorial.
factorial. Okay.
And they want the general term as well. So I'm going to go ahead and put plus dot dot dot. Now, if I extrapolate this pattern, it looks as though the exponent on x is going to be 1 less than the power on the 2 and the factorial here in the denominator.
Mm-hmm.
So I'm going to say, well, plus, if this is x to the n, then the denominator should be just 2 to the
N
1
plus
more, right?
one
So 2 to the n plus 1, and the
times n plus
factorial
one
matches the
factorial.
power times n plus 1 factorial.
Huh.
And then don't forget your dot 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 because this is an infinite series. All right, that should be part B.
Yep. That's exactly what they got too.
Cool.
The only they for the three terms they got that they wrote the general term the same. They just wrote it as instead of x to the n, they did x to the n minus one, and then instead of
Right.
n plus one, they used n. So
Yeah.
same
Okay.
thing.
That's cool.
Yeah.
But
Okay. Bet.
all
Nice.
right.
Okay. So it all stems from knowing the expansion of e to the x. It seems.
Yes. I mean, if you don't know e to the x, I mean, you're not totally cooked. You just have to build it from scratch, which
Right.
if you know it, you saves you a lot of
Yeah. I
time.
was about to say that seems kind of time consuming.
Yeah. Yeah.
Okay.
So, all
Okay.
right. So cool. That's parts A and B.
All right.
On to part C. So this must be a doozy in part C,
Yeah.
especially if it's only three parts. Like, dang.
Right.
All right. Let's see
And
if
this
I
is
can keep
all
this.
this is all off top too, mind you. So
This is off top. Yeah, I'm
he's
going
like
real,
that, ladies and gentlemen.
real
He's like that.
methodical. Oh man, I've done so many problems, man.
Yeah.
All right, so it says for the function g in part B, and I'm glad my part B was correct.
Yeah.
Find g prime of 2 and use it to show that the sum from n equals 1 to infinity of n divided by 4 times n plus 1 factorial equals 1/4. Okay, so let me go ahead and just write g over from part B. So I'm going to go ahead. I'm actually going to use the lasso.
Okay.
I'll do this. Boom, cut, and then paste. iPad is super clutch.
I know, bro.
All right, so this is g of x, right? So it
Okay.
says I want to find g prime of 2. I'm going to just differentiate this term by term
Yeah.
because this Taylor series is a polynomial and we can just differentiate polynomials term by term. So I'm going to go ahead and just do
Hmm.
that.
Okay.
So g prime of x, the derivative of a half is 0, plus the second term is just going to be the coefficient itself. When I do the derivative of x is just 1. So it's going to be 1 over 2 squared times 2 factorial. I mean, you use power rule for the next term. So the 2 is going to come down. So I'm going to have 2x over 2 to the third times 3 factorial. And so when I get to my general term, I have n times x to the n minus 1,
Uh-huh.
all divided by 2 to the n plus 1 times n plus 1 factorial plus
Okay.
dot, dot, dot. And the reason why I can do that is because I'm differentiating with respect to x. So all those n's are going to be treated like constants. All right, so now this is g prime. I want to find g prime of 2. Maybe I can cancel something from the general term because I notice I have this n and I have this
Hmm.
n factorial. N factorial is just, I know n factorial is n times every integer one less than it down to
Hmm.
1. So this is n minus 1 times dot, 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 all the way down to 1.
Hmm.
So I could actually rewrite n plus 1 factorial as n
N plus
plus
one
1
times n.
times n factorial,
Oh yeah.
right?
Yeah.
Or alternatively, I could say n plus 1 times n minus 1 factorial
Yeah.
because that will make the n's cancel. But then do I want to, how's that going to help me? Well, let's just maybe plug in 2. Yeah, I was trying to manipulate the general term. Like I try to go to the general term, but let's just plug
Hmm.
in 2 and see what happens.
Okay.
So I'm going to plug in 2. So I'm going to have g prime of 2 equals 1 over 2 squared times 2 factorial plus 2 times 2 over 2 cubed times 3 factorial plus dot, dot, dot. This is going to be n times 2 to the n minus 1 over 2 to the n plus 1 times n plus 1 factorial, right?
Hmm.
Okay, so then I'm looking at this, and usually when they want you to find the sum of a series, I want to figure out g prime of 2 is going to be the sum of all these terms in this infinite series.
Hmm.
Usually, the only series we know convergence values for is the geometric series. So I'm thinking this series is going to be geometric. So with the geometric series, we can tell it's geometric because there's a common ratio between the terms, meaning I have to multiply by a constant number to get from
Hmm.
term to term.
Hmm.
So let's see. So from this first term to the second term, what do I multiply by? Well, I know multiplying by a 2
Hmm.
in the denominator.
Hmm.
And maybe what I could do too, I can just divide these two terms to see if the ratio that way.
Oh yeah.
So 2 times 2 over 2 cubed times 3 factorial divided by 1 over 2 times 2 to the second power times 2 factorial. So that's going to be 4 over, we got a lot of 2's running around.
I know.
2 cubed times 3 factorial times 2 squared times 2 factorial over 1. So let's see what we can do. So we have 2 to
Could
the
you
2 and cancel out here to get a 2.
can you rewrite 3 factorial as 3 times 2 factorial?
I
Does it
can do
work like
that.
that?
Yep. So 2 factorial can cancel out here.
Hmm.
Then I'll be a 3 left.
Hmm.
So I get 4 over 6, which is just 2/3.
Okay.
So that's probably my common ratio,
Mm-hmm.
maybe. Um, let's see if I reduce this general term. I have 2 to the n minus 1 over 2 to the n plus 1.
Mm-hmm.
I can subtract those exponents, right?
Mm-hmm.
So n minus 1 minus n plus 1,
Mm-hmm.
those n's will cancel. And I have negative 1 minus 1,
Mm-hmm.
negative 2. So I have really 2 to the negative 2, which will be in the denominator is 2 to the 2.
Yeah.
So then this is going to be, the general term is going to be n over 2 to the 2
Mm-hmm.
times n plus 1 factorial.
Nice.
Okay, so then the question is, how do we find the sum? That's the general term. Yeah. So is that g prime of 2?
Yeah. N over 2 squared times n plus 1 factorial. Yeah.
Oh, bet. So, okay, I thought it was asking for a numerical value for g prime of 2. Okay,
Nope.
bet.
Nope. They left it like that.
Okay, bet. That's a good point though, because a lot of times, I mean, a student probably doing this would think that, oh, I should get a number for this.
Right.
But you could, I mean, this is a number. We don't know what it converges to, but it's
Yeah.
just the value. It's just the
Right.
infinite series itself. So, okay, so I'm going to go ahead and box my answer in. This is actually going to be g prime of 2. Yeah, I tell my students as long as you have the plus dot dot dot, that denotes that
That
it is a infinite
right.
series. So you're golden.
Okay. That dot
So I'm
dot
going to go
dot
ahead
seems like as important as a plus C.
absolutely. My kids miss
Yeah,
it all the
bet.
time and they get docked.
Yeah.
All right, so now it says use this to show that this sum equals 1/4. Well, I'm glad I actually simplified that general term because I see the n over 2 squared times n plus 1 factorial, right?
Mm-hmm.
So I know that g prime of 2, and this is probably where it's going to be useful to write this in summation notation, right? I'm just going to write this as the sum from n equals, I believe it's going to be 0. I want to get 1 for the first term. So that should probably be a 1.
Mm-hmm.
N
Mm-hmm.
equals 1 to infinity of n over 2 squared is 4 times n plus 1 factorial. So that
Mm-hmm.
is g prime of 2,
Right.
which that's the series they're asking about here, right?
Mm-hmm.
Which they're saying equals 1/4. So they're basically saying show that g prime of 2 is 1/4.
Right.
Think about what g is, right? We said that from part B, g was e to the x divided by 2 minus 1,
Mm-hmm.
all divided by x. So I'm thinking if I could take the derivative of that expression and plug in 2, I should get 1/4.
Right.
So that's what I'm going to do.
Okay.
So I know that g prime of x is going to be, and let me actually rewrite g of x first so I know what I'm doing. G of
Okay.
x was what? E to the x over 2 minus 1 over x. Okay. So e to the x over 2 minus 1 divided by x. I need to take the derivative, so I'm going to use quotient rule.
Mm-hmm.
So g prime of x is low d high. So low is x times the derivative of the numerator is going to be e to the x over 2, but then the chain rule says times the derivative of the exponent, which is 1/2,
Mm-hmm.
minus the derivative of 1 is 0, so
Mm-hmm.
close parentheses, minus high d low, so the numerator, times the derivative of the denominator is 1, all over x squared. So now we're going to plug in or plug in 2,
Two.
and hopefully we should get 1/4.
Right.
Let's hope. All right, so I'll plug in 2 here. G prime of 2 is going to be 2 times e to the 2 over 2 times 1/2 minus e to the 2 over 2 minus 1, and then times 1, all
Mm-hmm.
over 2 squared. All right, so then I know that 2 times 1/2 is just going to cancel out to 1.
Mm-hmm.
And then I have, that's going to be e to the 2 over 2, just e,
Mm-hmm.
minus this negative will distribute.
Mm-hmm.
So it's going to be minus another e plus
Plus
1.
one.
I'm seeing it
Yeah, I was about to say there it is. E's cancel.
over
2 squared
4.
is 4. Let's go.
E's will cancel.
Yep.
So that's going to be 1/4.
Nice. That
That's a good thing
looks
about
what?
like you know the answer you're trying to get
Oh
to.
yeah, 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 yeah,
Yeah.
yeah. I was gonna say
Um,
the key looks exactly like that.
okay, so then yeah, I can say, if you got time, if you want to flex on
Yeah, I was gonna say y'all see it for yourself.
Okay, okay. Hey, there we go.
Take a screenshot, people.
Oh
If you need
yeah.
to compare it, same thing. Let's
We
go.
valid. We valid over here.
Yes, nice. I want to know the
Um,
stats for that one. I bet a lot of people got cooked.
I want to know because I feel like as straightforward as the first two parts were,
Hmm.
I definitely felt that part C was going to be a little more
Yeah,
involved, and it was. It was.
nice.
Cool,
That's cool.
cool. Yeah,
Okay.
I think the only thing that would probably cause students pause, I mean, it caused me pause, was like whether or not you should get a number for
Hmm.
GPW 2. And so students being comfortable with getting an infinite series and not being able to find the sum of it.
Yeah.
Because we don't know how to find the sum of this series. So
Right.
roll with it.
Hmm.
So,
Okay,
and I
bet.
tell my students that a lot. I think in calculus, they're seeing a lot of more abstract answers. So, like,
Right.
sometimes the answer will be the cube root of 4. And it's like, that's actually an answer. You didn't do it wrong, right? Just be
Yeah.
comfortable with it not being a usual number you're used to.
Yeah. Reminds me of my on level kids when they get like a decimal as an answer. They're like, wait, I must
Yes.
have did something wrong.
Yes. Yes.
Yeah.
You know,
Nice.
yeah,
Okay.
that was a
Well,
banger.
shoot. I guess if this is your video, you got to take us out and do the outro.
Do the
Right?
outro. So yeah, that's the BC problem, y'all. We're gonna actually incorporate more BC problems as we go along. So series is a big topic that shows up on the exam. It's gonna always be question 6 on the exam. So there's a 99.9% chance you're gonna see a series question on the exam. So definitely make sure you're good on the series stuff. But also, in BC, there's parametric equations, there's polar equations, there's different kinds of integration techniques that you don't do in AB, like integration by parts, partial fractions, improper integrals. So stay sharp with your BC stuff as well, BC folks out there. We're gonna be dropping some more stuff at y'all as we go. So
Nice.
hope y'all enjoyed that BC detour. Make sure you like, follow, and subscribe. Mr. Loves to Teach, and
And
you are
I'm just Mr. Allman.
Mr. Almond with the sauce. With
Yes,
the sauce.
sir.
All right, we'll see y'all in the next video.
All right, bet. Peace out. That was a good outro.